Hi, I hope you're feeling well today. We're looking at exponential graphs or power graphs. The general formula is y equals a to the power of x. The key thing is to look at where x, the 0 point on the x-axis and where it crosses the y, and the 1 point on the x-axis where it crosses the y. So for this equation, this graph, the equation is y equals 2 to the power of x because it crosses at the point 1, 2. To convince you further, I've put the numbers on the calculator here, 2 to the power of 1, 2 to the power of negative 1, and 2 to the power of 2. So we get 3 coordinates. These coordinates come from this equation, then we're going to plot them on our graph. And you can see that all those points lie on the line. We also know that 2 to the power of 0 equals 1, so we can plot that point in there as that one. Here we have a nice smooth parabola, and the x-axis is called the asymptote. An asymptote is a line that the graph gets closer and closer to but never crosses over, so the bottom of the graph should look like that, getting closer and closer to the x-axis. In theory, it doesn't touch. Here I've got a graph y equals 3 to the power of x. This one here has been shifted up 5 units, so all that we do is we add 5 onto the x-axis, onto the end of the equation. This next one has been shifted down 5 units, so what do you think the equation is going to be? And here's a revealing fact and a little pun. In this case, we see that the graph has been shifted along 2 units to the right, so that's our clue for the equation. To work out the equation of this graph, check that you've got the point 1, 0. Check what the 1 value is. In this case it's 4, so here's the equation. That was easy. Another easy one, just check these values there, and write the equation. Y equals 10 to the power of x. This one here looks a little different. It goes downwards. All that we need to do is know which point the 1 is at. So if we know it's 1 and 0.13, we can write the equation y equals 0.13 to the power of x. Let's review our basic parabola. If we have y equals x squared and then make a transformation of that, look at the vertex. So here we have the vertex at 7, negative 4. Better hurry, police are coming. So the same applies for an exponential graph here. We see that we've got our basic graph in blue, and the red one has been shifted along 3, so there's our clue, 2 to the x minus 3, and it's been shifted up 2 on the y-axis. So here we can see that our red graph crosses at 2, our blue graph crosses at 3, and so we get those equations, and our pink graph crosses at 4. What does the green graph cross at? We can see it crosses at the 1 at 5, so we write the equation y equals 5 to the power of x. The blue graph is y equals 2 to the power of x. What's the equation of the green one? The asymptote is shifted up 3, and the 1 value is shifted how many along? And you can see the point, corresponding point, that this height is the same as this height here, shifted back 3. So the graph equation looks like this. Remember, the x value is a clue, so if it's been shifted negative 3, that's your clue to put plus 3. Let's try one more. The asymptote's easy enough, it's gone up 1, so we have plus 1 at the end of our equation. Then all you need to do is find out where the x shift is. Look at this. From the 1 point it's too high. It's too high there, so it would be a sideways shift of 3 units, so it's gone to the right plus 3. That's our clue, and we put x minus 3 there. See you next time. Well, I won't really.